This conference will now be recorded.
Good morning to all participants across. Thank you all for finding time and attending today's webinar. Myself, Pratibha Shanbhog, working as Assistant Professor, Department of ECE, BITM Ballari. Well, now I feel pleasure to welcome our guest who has honored us with presence as a resource person, and today's speaker, Dr. Neha Sharma. Ma'am worked with TCS and as a founder secretary of Society for Data Science India. Prior to this, ma'am has worked as director, Zeal Institute of Business Administration, Computer Application and Research. As well, ma'am has completed her PhD from prestigious Indian Institute of Technology, Dhanbad. In addition, ma'am is a senior IEEE member, website and newsletter chair of IEEE Pune section, and served as student activity committee chair for IEEE Pune section. Thank you, ma'am, for being very generous and considered it in accepting our invitation in spite of your busy schedule and spending your valuable time and joining with our broadcast today. Today's webinar session topic is Data Science, a journey from data to data products. Finally, I feel privileged to welcome all the participants for today's session. Thank you.
Very good morning to all the esteemed listeners and participants. At the outset, I would like to thank BITM, Bellary Institute of Technology and Management, and Dr. Malika Arjun for inviting me and giving me an opportunity to talk to all of you. And I hope you all are safe at your respective place and doing great. This is indeed a very challenging time for all of us, something which we have never seen in our lifetime. So the best thing which we can do is to adhere to the guidelines given by our state government and central government, and basically sharpen our own skill in the time when we are there at home working from home. So the time which we are saving from commuting, that time can be utilized for sharpening our skills. So with that, thank you once again for having me here and giving me an opportunity to share my ideas with all of you. I hope you'll find it insightful and interesting and exciting as well. So the topic which I have chosen is data science, a journey from data to data product. You know, the complete data product. But before I start this session, I would like to know the participants are from which vertical. If anyone can just let me know. Are they from computer science alone, or they are from mechanical or other branches also?
It is across the branches, ma'am.
Yes, sorry, I could not hear.
Across the branches.
Across the branches. Thank you.
Yeah.
So now, one thing is very essential for all of us to know, that data science is not pertaining to just computer science or IT. or somebody working in data science vertical. Data science is applicable to everywhere where data is there. With that, I'll just initiate my talk, and we will and try to give you as many as example to understand what is the scope and length and breadth of data science. So let me start it with a question like, what is data science? I mean, we keep on hearing this term every now and then. This is a buzz word and uh, very talked about term in these days. So let's try to understand this particular word by dividing it, data and science. So let's focus on what is science. Science is something which allows you to study the structure and behavior of anything. Like if you're studying the structure and behavior of an individual, then it becomes a behavior science. If you are studying a structure and behavior of medicine, that it becomes a medical science. If you are studying structure and behavior of, say, healthcare, then it becomes a healthcare science. So on and so forth. Likewise, data science, when you try to study the structure and behavior of data, it becomes data science. So it includes everything, right from identifying the data source, extracting the data source, then doing all sort of analysis with that, building up a model, visualization, then converting it into a product. The entire thing is called data science. The complete ecosystem is called data science. So first myth you need to take away from yourself is data science is only machine learning, data science is only Python. It's not like that. It's the complete world of data is called data science. And it is very essential for all of us, from whichever branch you are coming from, to know a little bit of data science, because I say like the way you are surrounded by oxygen, you are surrounded by data. If you do not make a smart use of data, then probably you are not doing much with the resource which is easily available to you, right? Now, before I proceed, I would like to share one report with you. This report is of a survey which was conducted in the year 2006. Now, the survey was to find out the top 10 leading companies of the world. And the result of the survey had 5 energy companies and 1 IT company. Right. So there was only 1 IT company, and that was also Microsoft. Rest others were not there. There were 5 energy companies. Now the same survey was conducted in the year 2016, that is after 10 years. In just a decade's time, with a blink of eye, the scenario changed. And now in the top 10 leading companies, we had 5 IT companies and 1 energy companies. Now, how did this happen? This happened because the companies realized that they have so much of potential in the form of data, which is lying there with them free of cost. They just have to pull it out, experiment it with it, do some innovation, and then apply some data science to find out some beautiful insights and help their business grow and to be there as a world leaders. In the same year 2016, I'm talking about 2016, in the same year there was an interview conducted uh, uh, by someone with ex-CEO of Google, that is Mr. Eric Smith. Now, Eric Smith, in that interview, he said that right from the beginning, right from the time we have started collecting data till 2016, we have collected around 5 exabytes of data. And in 2016, every 2 days, we are generating 5 exabytes of data. And he further added that, like by today, I mean, can you imagine that today we have around 3 zettabytes of data? And then he further added what I was telling you is, like he said, he predicted that by 2025, we are going to have 180 zettabytes of data. So that is huge data which he predicted, of course, as a result of some analysis and insights which he must have got through his team. He predicted that by 2025, we will have 180 zettabytes of data, which is huge. And today we have 3 zettabytes of data, as I told you, which is huge. Now I'll take you back to 2010 once again. Why there's a reason for me to tell you all these stories, so that you appreciate the importance of data science, and probably it should excite you. So just to build up to the entire session, I'm just sharing you all these stories. And of course, most important thing for data scientists is to be able to tell you these stories, what data is hiding or embedding in with itself, you know. So in 2010, before 2010, basically people were generating lots of data, but they were struggling to store it efficiently, right? They were literally struggling to store it. Now, by 2010, we had a structure or framework called Hadoop, Spark, or something like that, which allowed us to store big data, right? Store big data in a distributed manner on the cloud, and not only store, but also to retrieve it with the same speed. So our problem, which was there regarding how to store the data, it shifted from now how to store to how to process the data, right? So believe me, we are in the best of time where we are blessed with the technology which will help us in extracting data, analyzing it, exploring it, building up a model, helping us visualize it, and then to convert our all journey into a product, you know. If you do not believe me, I'm sure you will believe Tim Berners-Lee, the inventor of World Wide Web. He says that data is a precious thing and will last longer than the systems themselves. So everything is going to change, decay, or renovate, you know. But the only thing which is not going to change is the data. So you will have new technology, you will have modern gadgets, but you will keep on working around the data, which is going to be there as an immortal thing available to you forever, right? Mr. Vinod Khosla, who is a co-founder of Sun Microsystem, he says that in next 10 years, data science and software will do more medicine than all the biological sciences together. So look at this. This is a very strong statement, you know. So what medical sciences are doing, probably we as a data science team and data science department or vertical are going to augment their efforts, you know, with the kind of visualization insights which will help them to perform better. So indeed, a very, very important vertical which is emerging is the data science vertical. Moving ahead, let us define it before we proceed. So data science is a vertical which starts from, you will find many definitions, you know, but let me define it and redefine it for you throughout this session. So data science starts with identifying the location of the data, extracting the data, what is needed for your work or for your analysis, or to get the insight or the problem statement at hand, then clean it, prepare it, and then analyze it, perform exploratory data analysis, perform descriptive data analysis to understand what is there in your data. Then build up a model, get some insight, have some visualization to convey your insight, and then convert it into a product. So complete journey from data to data science, data product is your ecosystem of data science. Right. So that's the reason I have named the session as Data Science, a journey from data to data product, you know. So complete ecosystem of data science. Now, please do not get confused and use the term interchangeably. Data science includes everything related to data till the time it gets converted into data product. Everything comes in between. Machine learning, Python is a tool, machine learning is a model building, this thing, statistics comes in between, your computational knowledge comes in between, your domain knowledge comes in between, your communication skills comes in between, your data mining comes in between. So these are all things which are part of your journey towards building up a data product. So good morning. Hello, I am Dr. Neha Sharma, as introduced by one of the faculty, and I am here because I have been working in the field of data science for quite some time. And you can see more about my publication and details on drnehasharma.in. And as Madam has already introduced me, I don't think this is needed. One thing which is important and I would like to draw your attention is, I have in the year 2018, along with my academic career, I have spent around 16 years in academia, and right now I'm with TCS. And in the year 2018, we formed a professional society by name Society for Data Science. I am the founder secretary for this society. I was so passionate that we thought, let us give it a shape, otherwise it is not going to culminate in something very wonderful, something very useful for the society. And this is not for profit organization which keeps on working on various projects. We keep on engaging students, give them live projects, and help them understand the data science ecosystem in a very detailed manner, right? I have got 50 plus publication. This is old now, it is quite more. Now couple of awards to actually prove my credibility, and the award which is very close to my heart is Best PhD Thesis Award, which I got in the year 2015. So that was all about me, short and crisp, nothing much, nothing great. So coming back to the world of data science, it starts from, as I told you, it starts from data acquisition, then you go to data preparation, then you perform data analysis, then you build a model, visualization, and deploy and maintain. Let's look at it in slight more detail. You might be knowing or be aware of many of these things, but let us learn it as a story, because stories are easy to remember. I always conduct my session in a way that it forms a story, and you need not take efforts to remember what are the contents of the story, and that should be the job of data scientist also. So first step in this journey is to understand the business problem, and you will not be able to understand the business problem without asking questions. So you have to keep on asking so many questions unless and until all your doubts are clear and you understand everything very clearly about the business problem, right? And unless and until you perform this step properly, there's no point going ahead, because I mean, you have not understood the problem. So whatever you are going to build would be on wrong footage, right? So this is first and very important stage of life cycle of data science towards building a data product. Now, once you have understood the problem, you would like to gather some data. You might get ready-made data available in your organization, or maybe as open source data with government site, which they allow you to use for research, or you may get it on GitHub, or you may get it on Kaggle. So there are lots of crowdsourcing data available. Apart from that, you might need to go through web servers to get the required data. You might have to scratch some logs, fetch some databases, APIs. You need to hunt on some online repository to get the right data for addressing your problem statement. So this is, again, I will not say this is a less important phase, because understanding the problem and then to get the right kind of data to address that problem. We are working on this COVID related data, which everybody is working. I'm not doing a great thing. Everybody is trying to build up a prediction model. We are also trying to do it. Then I'm working on Kisan call center data set, which comes from Government of India. It is available on data.gov.in. You also can hunt for it. So this data records all the grievances or concern which farmers has raised. So that is so distorted data. Of course, it's an open data set, but data is in very atrocious stage. You can't just take the data and start working on it. Then third project which we are working on, tree census data and air pollution data. Now all these data has come from government organization. Now we have all the reasons to trust this data, but believe me, the data has been stored and recorded by people who are not an expert in handling data. So you have to first identify the right location of the data and then start working on it. So as I told you, the data which you will get might not be in right frame, right condition. You can't use it as it is. So you need to prepare the data. How will you prepare the data? There are so many steps. Just to keep it simple, I have kept two things, that is data cleaning and transformation. Now when you are looking at your data, you will find lots of inconsistencies in data type. Like you will have height in, maybe suppose you are storing height of tree, so height will be for some trees it will be in inch, some will be in feet, some will be in meter. Now you can't work on this data set. You need to uniform it, right? Or maybe something is in integer, something is in float, something is in string. So that also has to be transformed and brought to a consistent form so that you can start working on your data set. Misspelled attributes are a common facet, somewhere you will find data preparation as data prep, or just preparation, or data p, or something like that, which is indicating to same fact but through different terminology. So that also has to be corrected. Then you will find so many data which are not there or duplicates, so that has to be addressed before you move ahead in the life cycle of building a data product. So transformation, as I told you, like you need to transform the data so that it becomes uniform. I will give you one more example, like suppose I will give you the example of the same COVID data on which we are working. So along with COVID data, we have collected the data of hospitals available, doctors available. So in one data set, you will find the doctors or hospitals or number of beds available at the lowest granularity, like at PHC center, public health community center. That's a hospital hierarchy which is there, designed by government of India. So at the lowest level, you will have PHC, CHC, then you will have um, healthcare centers or something like that. There's a defined hierarchy. So in this some data set, you will find the details at the lowest granularity, and in this other data set, you will find it at the state granularity. So if you decide that you are going to look at from the state's perspective, then you have to roll it up and bring it to the level of state. Or if you want to look it from the lowest granularity, then you have to spread it out and bring the data to that level, gram panchayat or maybe block or subdivision level, right? So data transformation is equally important, and data cleaning and transformation are part of data preparation. Now, once you have prepared the data, you still don't understand anything. Data as per you is ready, but you still don't understand anything. So to understand what is the story in your data, you need to perform exploratory data analysis. Now, at some places you will find it as data analysis, you will find it as data descriptive data analysis, or you'll find it as exploratory data analysis. I have already told you. So business intelligence is another terminology, but whatever you call it, depending on the context, you actually do the same thing. You apply simple statistical method to understand what your data is saying. So like you want to know how much is your sale last year. So you will just find out a sum of a product and then you give it. So yes, when you perform simple statistical methods to understand, to explore your data, historical data, that step is known as exploratory data analysis. It helps in defining and redefining your data set. It helps you in selecting the right features, right attributes to design the model. And if you suppose don't do all these things and still go ahead with building a model, probably you will end up selecting a wrong feature attribute and build up a model, and then on you have built up a model on wrong footage, wrong features you have selected. You have not selected the right attribute to build up a model. So the model built in that way is not a right model. So this becomes again one of the important steps. Then fifth is our main step, that is building up a model. Now, depending on the type of data which you have already, you can apply n number of algorithms which are there. Like suppose if you have supervised data, supervised data, that means you have a predictive uh, attribute, you call it label attribute, target attribute, whatever you may call it. So target attribute is there in your data set. Using that data, you can always have a forecasting model build, or you can have a prediction model build. But if you have unsupervised data set wherein you do not have target attribute, then in that case you can perform some clustering, classification, association, or you can try to find out some pattern in that. Anything you can do. So depending on your data set, what you have, you apply a couple of algorithms. Once you have applied the algorithms, train the model with the training data set, and then test with the test data set. Now the entire data set, what you have, you initially divide it into two parts, that is training data set and test data set. Now you build up a model or train a model with the help of training data set. Once you have trained the data set, then you will have to test the model with the help of test data set to check whether the model is behaving in a right manner or not. Once you have done that, then probably you can select the best model, and you can always build the model using Python, R, SAS, whatever tools you are comfortable with, right? Python is my favorite, and you can still use anything. I mean, there are so many options available. Then once you have built the model, then you need to perform some visualization using the tools like Tableau, Power BI, ClickView, or something like that, and communicate your results with your customers or clients or whomsoever you have designed the model for. Now once everything is okay, everything is found correct, you have communicated it well, then it's the time to deploy and then maintain the model. So deploying the model means you are deploying it in the real time. Now by deploying, the story doesn't end there. Then you have to monitor it still closely, come out with charts and graphs on the real-time data set, and keep on revisiting the model again and again to ensure that it behaves in the expected way, right? So this was the entire journey of data science from to convert the data to data product. Let's look at what is data product. I mean, let's dive down a little more in the story and understand what is data product. Yeah, before I proceed, I would just like to know, I mean, I could see a few people are leaving. Is there any disturbance or voice is not clear or something like that from my end? Am I audible clearly?
Yes, ma'am, you're audible, and the video is also okay. There's no issue, ma'am.
Okay, fine. Yeah, so let's try to understand what is a data product. So as per Dr. DJ Patil, who is the first US chief data scientist, he says a data product is the product that facilitates an end goal through the use of data. So basically, when you build up a product with the use of data, is called data product, right? I hope it's clear. When you build up a product by using the data itself, it's a data product. There's slight difference, which I'll tell you. Probably you must not have even realized now, but I'll tell you what is the difference between exact data product and the product which are utilizing data but are not data products. So as we move ahead, I'll let you know. So let's do the formality of defining it. Data products are system models that help us to understand data in order to gain insight and make predictions. Right? So basically, you will build a product which will use data to help you gain insight and help you make the prediction so that you can see the future. You can predict the future. A few more definitions. A data product is the production output from the statistical analysis. So of course, a lot of statistical analysis goes in the data product, and you just intend to give the outcome of that, you know. So data product automates the complex analysis task or use technology to expand the utility of data informed model, algorithm, or inferences, right? So basically, the complexity of analyzing the data, building a model, everything is abstracted with the help of data product, you know. Let's try to understand Uber as a data product. We all have used it once or twice or many times or maybe daily, right? So we keep on hearing that AI and ML are going to change the world and IoT is going to make our life very, very easy and simple. But what is the underpinning thing which is going to make this all revolutionary technology work for us? The underpinning thing is the data itself. You know, whether it is AI, whether it is ML, whether it is IoT, whether it is blockchain, whether it is robotics, you just name it, and data is the underlying core of every new technology. From social media to IoT, a lot of data is generated. You know, you are on Twitter, Instagram, LinkedIn, Facebook, then IoT devices, gadgets, sensors, camera, everything is generating exponential data. Now exponential word is also not enough to explain the growth of data. You know, the speed with which the data is getting generated is profuse. Let's have a look at Uber. You know, Uber basically you take a ride to move from one place to another. Now, Uber does not own any car. Not a single car is owned by Uber. Still, they are very rich. So what is that which is making Uber so rich? Of course, no investment on infrastructure, capital investment is totally zero. So that is one thing. But what is that makes Uber rich? Is it the availability of cabs or their service? It's neither the availability of the cab nor its service. It is the data which makes Uber rich. Now the question is data enough to grow any business? How do you get the insight and like knowledge and information and prediction with the help of data? How do you draw a beautiful insight to solve the problem? Now here comes the data science in picture. Data science is a process of using data to find solutions to predict outcomes for a problem statement. So you have data, you have problem statement, and you use data science algorithms to solve the problem. Let's look at it in more detail. Let's look at one of the situation where data science is using, Uber is using data science. There are many applications in Uber alone, but we are looking at one application wherein Uber is making use of data science algorithms, right? So Monday morning, you want to go to office, you try to reach the office on time because you have some meeting, but when you try to book a cab, you find that the rates are very high, right? So how does this happen? Because there is high demand, number one. There's high demand at that particular time for cabs, and higher the demand, the request for cabs and the fare will keep on increasing. So you know this is a supply demand supply equation, so more the demand and less the supply, the rates will go up. That is but obvious, right? So how Uber takes care of this demand supply situation? So Uber immediately activates search pricing algorithm. Now this is your data science algorithm. It's not just data. That's what I have been telling you right from beginning. It's not just the data. It's the algorithm which is applied to the data. It's the clarity of the problem statement. So everything put together gives you a beautiful product like Uber, right? So Uber activates the surge pricing algorithm at the busiest location, the location which is very busy, where the demand of cars are more, and it activates the surge pricing algorithm to basically get more drivers on road. And it is not just like that. It is guided by principle, right? It is not haphazard. It is not random. It is guided by principle. It ensures that everybody who asks for a ride should get a ride of his or her own choice. So it is guided by principle. It ensures that marketplace is balanced properly, right? Surging price automatically goes into effect when there are more riders in a given area than available drivers. So you have more people who are looking for a cab, but you have less number of drivers. This encourages more driver to serve the busy area over time and shift the rider demand to maintain the reliability and store balance. So basically it's all the equation of demand supply, So in the peak hours, basically demand is more, supply is less. So to encourage the drivers to go and serve the customers, the rates are increased. And it is not only that, it basically also gives the guidelines to the customers or the rider that if you are not in an urgent situation, please wait for some time, let the price come down, because maybe after 1 hour the price might come down. It's a peak hour, So both ways it is helping to find a solution and strike a proper balance. So as I said, for drivers it's an incentive, and for rider it's a premium. Keeping it effective and accurate is the sole objective, and surge pricing works because it is closely tied to the level of marketplace imbalance. So it's directly related to it's working fine because it's directly related to your demand supply. And here's how you try to balance your reliability of drivers and the riders both. The entire surge pricing algorithm is algorithm controlled. I mean, that's an algorithm itself, So you can't manipulate it. It's an algorithm. The moment you give the data, it will give you the result, right? And the algorithm automatically gets activated when the demand goes up. And how do the system knows that demand has gone up? Because they are taking real-time updates, continuous updates about demand supply in a particular area at a particular time is being recorded, and that is where your algorithm either gets activated in case of requirement or remains deactivated. And one more feature and factor which you need to know is like entire area where you are staying is divided into zones, hyper local zones, and the demand supply is recorded on the basis of this hexagonal zones which are shown on your screen, left bottom, right? So you may have high demand and supply at one particular hyper local zone, whereas at other places it might not be there. So it keeps on shifting. One of the more important feature of this algorithm is to ensure that this keeps on shifting, this load keeps on shifting. It does not remain there. They might pull out few more drivers from different locations by tracking or something, who eventually are there in that particular zone. So that way also it is activated in that manner also. And other additional factors, as we have already discussed so many times, it is basically to strike a good balance between drivers' motivation and riders' requirement, right? So let's look at it as a data product building exercise. So step one is to understand the business requirement. So business requirement, when we understood, and I hope you remember, I just told you a while ago that you need to ask so many questions to understand the business requirement and before you frame it. So business requirement, after asking so many questions, can be formalized in this manner. To build a dynamic pricing model that takes effect when a lot of people in the same area are requesting rides at the same time. So demand supply optimization problem. The second step, I hope you remember, is data collection. So Uber as such keeps on collecting so much of data regarding traffic, regarding weather, regarding pickup and drop location of various customers. So many things it keeps on collecting, right? So data is getting collected automatically by Uber. Third step is data cleaning. Now, when you are collecting the data, you end up collecting something which is not essential for this problem statement. Might be essential for some other problem statement, but not essential for this problem statement. So it's better to drop that to solve this problem. Otherwise, it will increase the complexity of the problem. So like the data regarding restaurant, theater, hospitals are not needed in surge price algorithm, you know, so that needs to be dropped. Step 4 is data exploration and analysis, because you have prepared the data but still you do not understand much about your data. So it would be a wise idea to analyze the data, perform data analysis using simple statistical method, and understand the pattern of your historical data so that you can build a right model by choosing a right attribute and features. Fifth step is to build up a model to predict search pricing at a given time and location. So like the entire data set which you have created has to be divided into training data and test data, and then machine learning algorithm is built and then trained using training data, tested using test data. At the moment you get a new data, you actually test it with that also, and then see whether the model is working fine or not. So once your model is ready, you need to validate the model. You have checked the model, you have built the model, you have checked the model with the help of test data, you have built the model with the help of training data, right? Now you need to validate whether whatever you have built with the historical data is correct or not. So the moment you get a new customer booking, you can validate your model. You run the new data past your model and see whether it is giving you the desired result or not. In case if it is not giving, then the error has to be conveyed to data scientist at Uber, and who will probably fix up the problem. Once all the problems are fixed up after data validation, then it's the time to deploy your data product and optimize it, you know. So you actually deploy your data product at various location to various customer clients everywhere, and then start getting their feedback. Once you get their constructive feedback, you again go back to your data scientist, ask them to make the required corrections, and then probably your model is far better than previous model, you know. And one thing which we need to keep in mind is this is a model, you know. This will predict, this will act, and this will also evolve with more data. So the model which is looking correct now may not be correct tomorrow. So it is very essential for you to keep on looking at the model. You can't just build a model and leave it to function. It's not a machine, it's a model. You need to understand that. Data, I mean, another product embedded in Uber itself, very interesting. It's a data visualization tool to just visualize the number of accidents happening in UK, So I have just converted a GIF on your screen, and see how beautifully data visualization shows what is the road safety situation, how many accidents have happened, what are the serious accident, what are not so serious accident. So Uber also gives you data visualization tools which you can use and see for yourself, right? So Franziska Bell, who is head of platform data science, Uber, says that data science project at Uber fall in 4 life cycle stages: data exploration, iterative prototyping, productization, and finally monitoring it. This is what we have been discussing right from morning. So you explore the data, you keep on building the model by iterative process, then productize it, and then you don't leave it, you keep on monitoring it. Each step can be optimized. There's lots of potential to come out with innovative idea with whatever work you have already done. So each step can be optimized, but the first thing which you have to start is the data. So that is what are the views of Ms. Bell. There are other data products also. Uber was one. I hope you like this story. Must be knowing it. I have just put it all together just to make sure that data as a product is appreciated and you understand what is data product. I mean, what is the difference between product and data product, normal product and data product. So other data products are like Amazon, Facebook, Netflix, recommendation system, so there are so many, and they say like Amazon, Netflix, and their a big share of profit is through recommendation system. If suppose you have used Amazon to look at some shoes on one of the day, and then you don't buy it, you just leave that site. You thought you will just try to find out what are the rates and what are the available stock, but you don't buy it, you leave the site without buying, you leave Amazon without buying. So next day when you go to YouTube, you see that all those things which you had seen yesterday are popping up again. Then you go to your Facebook, again you find the same advertisement popping up. So this is what is called ad recommendation, and how it is achieved is like Amazon data science team or data scientists behind it, they gather your browsing pattern and or other details about you and keep on throwing the information that, see, you were interested in this, you wanted to buy this, come back to us and purchase, right? So that is very interesting. We all have experienced it. Another interesting data product is your Apple Watch. Now Apple Watch is not just a watch, it's an intelligent device, and it has saved a person from a heart attack which happened in mid of night where no help was available, and just because of Apple Watch he was saved, he could save. So how does it happen? There's lots of data science again here, because there's lots of data, because this device which is called Apple Watch keeps on monitoring your health continuously, keeps on collecting your heart rate, your sleep cycle, your breathing cycle, your activity level, blood pressure, and so many other details 24/7 continuously. It is not possible for any hospital, any doctor to do it for you, right? And collecting that data, they keep on analyzing it to find out any disturbance in the pattern is there. The moment there is a disturbance, there will be an alarm which will be raised, and probably that was the reason the person Scott was saved from the heart attack. So data science is doing lots of good for the community also. The other data products are like credit card fraud detection, because you have so much of data. Of course, you can always have a data science product built on this. Virtual assistant like Siri and Alexa, which keeps on talking to you and serving your request. My Alexa got reactivated, the moment I said Alexa and trying to say something, prompt me something, from the backside. So that is amazing. Then you have self-driving cars, which is a beautiful, beautiful example of data products, where you have AI built techniques and beautiful product, which is no more just a mechanical car now. It's software, full software, right? So interesting products are there, which can be categorized as data products. Now, it is very essential for us to know that is everything on the web is a data product, because everything on the web is related to data. So is everything a data product? All the web products use data after all. I mean, why this doubt? Because everything on the web is using data, consuming data. So can we categorize it as a data product? And most of them, they use data to facilitate an end goal. So our definition, which we just saw a couple of minutes back, that when you use data to achieve the end goal, that's a data product, right? So most of the web-based things, they use data to get the end goal, to achieve the end goal. So are they all data products? So two things, right? Everything on web is revolving around data, that is number one, and they achieve their end goal with the help of data. So just because these two things are being addressed, which were there in our definition, are these product or data product? So very, very important question to look at it. Now look at this Medium. Medium is a world-class publication portal which published undiscovered voices, topic of your choice, or something like that. So Medium is an online publishing platform to help you find compelling ideas, knowledge, and other perspective. So online publishing platform which use lots of data, but the end product is publishing platform. End product is not a data product. That you need to understand. So you have Medium as a publishing platform, you have Medium search engine, you have Medium's article feed. So Medium is a publishing platform, whereas Medium has got sub product, which is a search engine and article feed. So Medium is not a data product because it is using data, but not for building up a data product, for building up a publishing platform. Whereas Medium search engine, it uses data to build a data product, that is your search engine. End product is also of data. Then Medium's article feed, like what data to push in front of you, that is also a data product. So not all or everything which is available on web is a data product, but some part of it can be a data product. Now, three things which are very commonly used: Instagram, Gmail, Google Analytics. So is Instagram a data product? No. Why no? Because it's just a photo and video sharing social networking service owned by Facebook, right? It is a sharing platform, but much of its functionality, like tagging, searching, discovery, can be considered as data products. Gmail, no. Gmail is also not a data product. Gmail is an email service whose primary objective is to allow asynchronous written communication between the individuals. However, sorting of important and non-important emails is a data product. The primary objective to sort email, and that is centered on natural language processing, right? I hope you are understanding the difference between what is data product and what is not. So we started off with the definition wherein we use data to achieve the end goal, right? So as per that, everything is fitting in. But here, end goal should also be related to data only, like in sorting, like in tagging, like in search, like in performing discovery. Now look at Google Analytics. This is a data product because its primary objective is bringing the quantitative understanding of online behavior to the user, right? So it uses the data to understand the behavior of the user, which is again a data product, right? Yeah, I heard somebody said something. Is there anything which I can help with?
No, ma'am.
Or can I proceed then? If nothing is there?
Yes, ma'am.
I hope audio is okay, clear?
All good, ma'am. All good.
Okay, thank you. Thank you for confirmation. Now, before we close, there are a couple of things which we need to know regarding this. What are the types of data products? Data products can be broadly classified into 5 types: raw data, derived data, algorithm, decision support, and automated decision making. Now, first 3, raw data, derived data, and algorithm, are basically utilized by the technical consumers, and mainly within the organization. But in some cases, basically, it may be used outside the organization also. There are a couple of examples, like when you have APIs, when you have ad exchanges. So in those cases, you just give the outlet. Otherwise, these 3 types of data products are basically generated and consumed within the organization, right? And mainly by technical consumers, whereas decision support and automated decision making are basically consumed by technical and non-technical people also. So decision support is kind of product which help you take a decision depending on your dashboard graphs, which has been generated using the data accumulated, right? Whereas automated decision making is like when you use machine learning and train itself, help it train itself on the basis of the amount of data which is coming in. It's called automated decision making type of data product. So example of decision support type, that is 4th type, is like Google Analytics, Flurry, WGNS, whereas the examples of automated decision making data products are self-driving car. Now, self-driving car recommendation system and all those things are a very automated kind of data product, wherein, like, if I have to give you example of self-driving car. Now, self-driving car has got so many gadgets, so many sensors, cameras fitted into it. It keeps on a communication device. It keeps on sending the data, receiving the data. So much of communication is happening. So the car is well aware of its surrounding. Car exactly knows what is there towards its right, what is there towards its left, what is there in front, what is there in back, when to speed up, when to slow down, when to take U-turn. It's all automated, and the decision making done by the car is also automated. So very, very like fine utilization and product of data science, data product. Interaction with the data product. Now you have the data product. At many times it's not tangible, you can't see it, you can't touch it. You need to interact with it. So how do you interact with it? You can interact with it with the help of APIs. And now APIs are meant for basically technical consumers. Then you have dashboards and analytics through which you can interact with data products, mainly for semi-technical consumers. People should have some statistical knowledge to use this, and web element for everybody, basically. So there you can have voice, robots, augmented reality to help in communicating why or how the AI has reached that decision, right? So the data products can be interacted with the help of these three mediums. How do you develop a data product? What is the strategy behind it? It's very simple. You have to aim, you have to know the business objectives, you should understand what is the opportunity, why are you doing it, what are you trying to achieve, have the understanding of policies so that you do not get into any kind of legal problem. So understand that, plan it very clearly, precisely, and in case if you are required to do a iterative work, please do it, but then planning is the foundation of anything. And then once you have done the planning, go ahead and design your product. And how do you design the product? Communicate the goals, have a clear understanding of what are you trying to achieve, build a team, share the data, adopt for new situation, and integrate analytics. It looks simple, but it is not simple. But then it is my job to ensure that all the complicated concepts are being conveyed in very simple manner. And it is not rather complicated also. Once you understand it and once you get the hands-on and knack of it, then probably it's not complicated as well. So with that, probably I think I have told you the entire journey of data science from data to data product, and I hope this will excite you to take up few data science projects in your vertical, wherever you are working, whether it is mechanical field, civil, electronics, whatever you are doing. I mean, everywhere you can have its application. In fact, we are more focused on application part of it. In fact, as my portfolio and TCS also, I'm looking at few of the projects pertaining typically to this data science only, right? Data for good kind of thing, you know, data for society kind of thing. Future of data science is very, very bright. It is going to stay there till the time you have data. You will have data science. You will have more increased role. You will have everything defined very clearly. You will have more jobs. You will have data science included in the curriculum also, and you will have ML to foster data science. So how are you going to achieve data science? It's of course through ML and its advancements, right? Now to just tell you a bit about Society for Data Science, I have already told you that Society for Data Science was formed in 2018 January. So now it is 2.5 years, but believe me, in just 2.5 years, we bring on table more than 150 years of experience, you know, more than a century years of experience, because the kind of people associated with us are very, very experienced, very senior people, and comes from all the walks of life. So we have I have a good experience in academia. Now I am with corporate. I have started my journey with corporate, and now again I am with corporate. So very beautiful blend of both the sides of the table I have. Then we have a person from defense background, then we have a pure senior academician, researcher, then good team we have, and we work on a vision of creating a very powerful data science ecosystem, and our mission is to ensure that the data is being used in responsible way to enhance the academic ability to solve the business and society problem with the help of data, to enrich the knowledge of student and everybody in the ecosystem, and adopt the multidisciplinary approach. So this looks simple, looks very interesting, and we are all passionate, you know. So this is all our like second parallel thing which we are doing along with our job, because we all want to do it. So the objective of Society for Data Science is to have a good, strong think tank who can guide and advise and do something for government to help them create better India, have good alliances, educational initiative is our responsibility rather. We keep on conducting seminars and conferences. We ensure that everybody who is related or associated with Society for Data Science is empowered. We try to find out data science solutions for many real-time problems. We have partners. We also recognize people. We keep on publishing good papers, good articles at very good places like Scoopus, Web of Science, work on real-time applications, try to contribute in building data science standards. And most important is like we try to have a better future for our youngsters who are going to be there after us. And of course, we also create center of excellence at various forums, very niche verticals like agriculture and like environment has been taken, water has been taken for working, and of course we have certification programs. So it's not a typical professional society which keeps on organizing activities and just that. We have a very high objective and we want people to join in because any big thing cannot be done alone. So we want more people to come with us, join hands, only passionate people. And this is our flagship conference of Society for Data Science, that is 5th International Conference on Data Management, Analytics and Innovation. And this time, this is the 5th version of it, and this time we are going to have it in Kolkata, Science City, from 15th to 17th January 2021. First two versions of this conference were organized in Pune, Maharashtra, and third one was in Malaysia, Kuala Lumpur, and fourth one was in Delhi, and this 5th one, as I told you, it's in Kolkata. So we have revised our tracks this time to make it more focused with our theme. And you can see the 5th track is totally on this COVID and pandemic thing. And the best part of this conference is like the proceeding goes in Springer's AISC series, very prestigious series it is. And then it is indexed in Scoopus and Web of Science. So get your good, genuine work published in good place, so that it is visible, it is cited more, and more people get benefited by your good work. So that is what is the objective. And we do not we are not working very fast pace, because we do not want the quality to be compromised in any way. And that's the reason. So we are going slow with whatever we are doing, whatever time available to us, but then quality is never compromised, right? With that, I hope you have found this session useful, exciting, and some knowledge, of course, has helped you in some way. I hope to get your feedback, and you can write me on nvsharma@rediffmail.com, and you can always call me. My phone number is there on your screen. Thank you so much. Thank you so much to everybody who has worked towards organizing this. Thank you.
Thank you, ma'am, for joining with us today and giving a vast insights on today's webinar topic. I hope all the participants would make use of this for your career and research work. Hope to see you again in the next topic. I would also like to thank our beloved HOD sir, principal sir, BITM management, and webinar conveyor coordinators, and most importantly, all the participants for providing the platform and joining with us on today's broadcast. Thank you one and all.